let's discuss how to compare different models. Up to this point, we've trained 3 classification models on the IRIS dataset. We created a logistic regression model, a decision tree model with a maximum depth of 7, and a k-nearest neighbors model with k equals 15. And then we used each of these 3 models to generate predictions for a single new iris flower. And we saw that all 3 of these models agreed that the new iris flower was likely to be a setosa. It's not always the case, though, that different models will agree in their predictions. In fact, these 3 models will not always agree in their predictions. Let's illustrate that with an example. So here I've created feature lists for 4 new iris flowers. The lists are named observation 0, observation 1, 2, and 3. So each one of these variables, each one of these lists is a list of feature values. So for example, sepal length, sepal width, petal length, and petal width. So I'm going to store the features for each of these observations into a new list called xnew. So xnew in this case would be a list of lists or a 2-dimensional structure. And we're going to generate predictions for all 4 of these flowers at once by providing xnew to the predict method of the of the model that we want to use to generate the predictions. So here we are generating 4 predictions according to model 1. Here we are generating 4 predictions according to model 2. Here we are generating 4 predictions according to model 3. Okay, so let's run this and see what we get. Okay, so for model 1, we predicted the first flower to be versicolor, the second flower to be virginica, the third flower to be versicolor, and the fourth flower to be virginica. Just to display this output in maybe a slightly more readable format, let me convert it into a data frame. So here, I'm going to generate the same predictions that I did above. I'm storing those in a list. This would be like a list of arrays. And then I'm converting the result into a data frame that I'm calling predictions. Then, just to add some annotation, I'm going to assign some names to the rows and the columns. And then I'm going to display this resulting data frame. So let's take a look and see what we have. So with this data frame, each row shows the predictions according to a particular model. So here are the predictions according to the logistic regression model. These are the predictions according to the decision tree model. And these are the predictions according to the k-nearest neighbors model. And then each column gives us the predictions for a particular flower. One thing we see is there's a lot of disagreement between the predictions according to each of the models. The 3 models all agree that observation 1 is virginica, or is likely to be virginica. But that's the only flower on which they agree. In fact, models 1 and 2 disagree on every other flower, except for observation 1. Models 1 and 3 agree on most of their predictions, but they do disagree on observation 3. Model 1 claims that that is virginica, and model 3 claims that it is versicolor. So this seems to be an issue. We have 3 models that are generating seemingly very different predictions for different flowers. Now, it turns out the situation is not quite as bad as it appears. In truth, there is really a lot of agreement between these 3 models, models 1, 2, and 3. I happened to have picked observations here that would sort of exacerbate the differences between the 3 models. But again, they actually do agree on most observations. But nonetheless, I have 3 models that generate 3 different predictions. I need to determine some way of picking one of them to use for my actual predictions. So it turns out that a common way of doing this is to use the model's accuracy. We're going to score each of these models according to their accuracy.